your midterm exam, by the way?
Right early.
So I got some questions from your notes taker. That's the point of contact. And they sent me some questions that I have to review. That's what I'm going to do now. Okay. The first question that I got is, how do you locate ghost images on hands, and how do you distinguish ghost images from the double images, right? So let's start with Gwen. What do you understand by ghost image?
I remember the example of the earrings, with the earring on the right side, and on the left side you can see fainted images. That's a ghost image.
Okay. And what is double image?
Double image?
Yeah.
No. I don't know.
Can you, I know you're eating. Can you talk a little louder, please?
When objects are located in the midline, they can appear both on the left and right side of the image.
Okay. How do you differentiate ghost images from the double images? That's the question.
Those images appear superior on the opposite side,
Uh-huh.
and I believe the ghost image is larger.
Okay. Horizontally, they will be magnified. And how about the double images? What happens to the double images? Will they be magnified or not? Okay. So you get the concept, right? Meena?
Yes.
So for example, like here, if you can understand this image, you know everything about the ghost and double images. So let's take a look at this picture. The blue thing that you're going to see, don't worry, I'll post this one on your canvas, so you guys are eating lunch, so please eat your lunch, enjoy your lunch. So here, whatever the structures that are present, you're going to see as a double image. For example, in the sense, like cervical vertebrae, it is in the midline, right? So since cervical vertebrae, when the X-rays, like for the panoramic image, it goes and captures twice. So that's one of the reasons that you are going to see as a double image, because it's in the region. Okay? Like for example, in this region, like the structures that are falling in this region, that's where you are going to see as double images. So for example, this is the hyoid bone, right? You're going to see two hyoid bones, because we don't have two hyoid bones, but there's one, because it is capturing twice, you're going to see as a double image. And what happens to the ghost images? Ghost images are in this region. For example, like earring, right? So it is from the X-ray source, and there is a center of rotation. Center of rotation is this area where the X-ray unit will go. So if you see something between the X-ray source and the center of rotation, those are the structures that you are going to see as ghost images. If it's in the midline, like in this region, you are going to see double images. For example, soft palate, hard palate, hyoid bone, epiglottis. These are all the structures you are going to see as double images. Okay. Ghost images, like for example, earring. Any questions with this? It looks like a full house. So I should have more review sessions rather than the regular sessions, right? Okay, the next question that was brought to me is like line focus principle. Okay. So you guys know cathode and anode, right? That's in the X-ray tube. So cathode is what? Charge. Negatively charged. And anode is? Positive. Okay. Excellent. From cathode to anode, what is going to happen? electrons they travel, right? So there is a kind of a little focusing cup like this. From there the electrons will boil off and reach the anode. So if you look at this particular image, here this is the cathode and anode. If you look at the anode, it's not like straight, as if somebody has taken a knife and cut it, right? Like it's at an angle. It's not like straight, it's like this. The way they are going to do, like putting like this, is they are going to tell the electrons or make the electrons hit only portion of it, not the whole length. Why they want to do it? If it's going to hit the whole length, then you're going to increase the focal spot. If it's going to decrease or hitting the point at only one smaller area, then you'll get a prettier or nicer image. So they want to reduce the electrons that are hitting the anode. And they do it by giving a 20-degree angle. This one. That's called as line focus principle. And why do we do this? To get a sharper image. Smaller focal spot, you'll get a pretty good image. Any questions? Yes?
That's only at the anode, right?
That's only at the end. Okay. Why do we use two different units? Anybody from other than United States? Which country are you from?
Canada.
Canada. What do you use for filling gas? Liters. Why don't we use the same thing here?
You should.
That's not the answer. Because we are special, right? So we use gallons, right? The same thing with the X-ray units. We do have something called as SI and the other system. So 1 sievert is equal to 1 grit. That's all. It's just a conversion, like 1 gallon is equal to 3.84 liters, right? Something like that.
I think.
So 1 sievert is equal to 100 grams. Again, remember, I'm not going to ask you for midterm or your final. It's good that you should know this one. Like 1 gallon is equal to 3.4 liters. Because sometimes you may go to Canada and start calculating, what the hell is this? Liters. And they use kilometers, we use miles, right? 1 mile is equal to 1.6 kilometers. Something like that, okay? Okay. Linear energy transfer. What do you mean by that? Anybody with physics background? Don't be shy. Nobody? That's unbelievable. I can't believe it. Yeah, basic physics. Yes, that's, yeah.
Yeah, I mean, I took basic physics, but I also didn't study for it.
So, anything that is moving through the matter, they'll lose energy, right? That's called as, in our case, we are talking about alpha particles, beta, gamma, and X-rays. Alpha particles, they have very high energy. So that means they have very high energy. X-rays, very low energy, low energy. So as they go through the matter, they're going to lose energy. So, for example, we talked last week, if you guys remember, that we are supposed to stand like 6 feet away from the X-ray source. Why? Why only 6 feet? Why can't you be at 10 feet or 3 feet?
That's the distance at which it loses its energy to its capacity to affect itself.
Yes, can you be a little more louder so that everybody can hear?
That's the minimum distance at which it loses its capacity to affect itself.
So that means after that 6 feet, we think it's safe because it has lost all the energy to penetrate. Alpha particles, on the other hand, they have very high energy. So that means they have very high energy, but they cannot travel. So as you know that it is done, or if poisoning was done with the tea. One example I gave with the Russian spy. Yes.
You said you can't be 10 feet. Wouldn't 10 feet also be okay?
Yeah, 10 feet be okay, fine, but 6 feet is the recommended. Yes, you can stand 10 feet, yeah.
Okay.
Yeah, yes.
Why alpha particles typically block by why would they travel?
Because they don't have a lot of energy to travel. Basically, you need so much of energy to penetrate, right?
But they got the highest energy.
Yes, so here, okay. LED is like as they travel, they have so much of energy to release and they don't have anything beyond that. So that means they have, although the, okay. But now, just remember, alpha particles, they have very high energy things and they are going to lose immediately. And X-rays, they have very low LEDs. But, okay. And although we are not dealing with a lot of other energies like gamma, for example, you know, anybody from Russia or USSR, former USSR? Come on, guys. Nobody? Anybody from former USSR? Okay, heard of Chernobyl? Yes, what do you know about Chernobyl?
It was a famous nuclear meltdown. Actually, I think it's still don't grow there very well.
So what happened there?
It blew up. A power plant.
Yes,
Power plant.
yes, there was a power plant, right? And it blew up, right? That's exactly what has happened. So, but there was some remnants that are still present. So, take out that they told one person can get so much of radiation. So within a minute, they have to go and capture that material, bring it back, and then put it in concrete. So that means the person got the whole lifetime of radiation. That's what they did in that country. Again, not going into the details. So every person, they have a restricted amount of radiation, or only so much is allowed. Either it could be occupational or it could be public. So remember, alpha particles, they have very high energy LEDs, X-rays, low energy LEDs. For now. Okay, what is the difference between added and inherent filtration? What do you understand by filtration? Yes. Can you be a little more louder?
Yeah. It blocks the low energy photons and allows only the high energy ones to pass.
Why do we do that?
To reduce the collateral radiation to the patient.
Yes. So there is something called as inherent. So that means manufacturer will add some kind of filtration. Okay, so aluminum. For example, like if we are using 70 kV, then we are supposed to use anywhere between 2 to 2.5 millimeters of thickness of aluminum. It will reduce the low energy photons. The example that I gave you was, you guys got into dental school, right? There is a certain amount of DAT score that is required, right? Maybe 20. Anything less than 20, we did not take. Why?
Less likely to succeed. Less likely to succeed.
In this case, yes, less likely to succeed. So that means we don't want the low energy photons. Low energy photons, they will cause scatter in this radiographic image. So we don't want those low energy photons to come into the picture. So we are trying to eliminate. And on top of that, we use something else, right? Added filtration, like we can use collimator because we are reducing the dose. So that's the added filtration that we are doing. The inherent is basically FDA says that this manufacturer has to add aluminum that's like anywhere between 2 to 2.5 millimeters of aluminum. and it will reduce the low energy photons. Okay. Stochastic effects versus deterministic effects. Anybody from the back? I'm still struggling with your names. Yeah. Not this. I'm pointing to you only. Not this. Yeah. What's your name?
Sam?
Oh, no. Behind you. Jennifer, okay. Yes, Jennifer. Go ahead. What is the difference between stochastic effects versus deterministic? If you have not read, then it's fine. You can say, okay, I'll pass this question. Okay.
Stochastic effects are all or nothing. So
Your name, please.
Natalie,
Natalie, okay.
they're all or nothing, so they're not dependent on the dosage. Like getting more of it doesn't make it worse. You either get it or you don't get it.
Mm-hmm.
Which is what we have in, like with dental radiation versus deterministic effects, which are like dependent on the dosage. They get worse as you increase dosage.
Yes. So basically, stochastic, it means what we believe in diagnostic radiology is that even one single photon can cause cancer. That's the whole idea that we are using. Okay? Whereas deterministic effects, that means that you need to have certain amount of dose to cause some kind of damage. Here in this case, it could be a cancer or some somatic disorder or mutation. Okay. The other thing is diagnostic radiation is patients, they tend to occur like we experience stochastic, because even one single photon can cause cancer. That's what we are trying to see. It's not on the deterministic effects. Diagnostic thing is not, because say for example 100 gray you have to give to cause cerebrovascular damage, right? So this is dose dependent, which we are not going to see with the diagnostic radiology, but you could see with radiation exposures, or if there is a plant that blew up, people could get more radiation, right? That's an example for deterministic effects. Working in nuclear plants, example. Okay?
I've got a question.
Yes, one question is fine.
This one. So in your PowerPoint, there was a slide that had a graph of the deterministic versus stochastic. And in that, you said that stochastic is more of a linear growth. And I'm confused as to how that is all or none when it's a linear growth.
So basically, all are, okay, so there is also something called, which we did not discuss in the class, is linear threshold and non-linear threshold. Probably that's what we are referring to.
Yeah.
Yeah, so there what we are saying is, again, linear threshold, as the dose increases, there will be some damage.
Okay.
So which we did not discuss in the class. I thought that it's not relevant, so don't worry about that.
Okay.
If you, let's keep it a review like a review session.
Okay.
So don't worry about the linear, non-linear threshold principles. Okay?
Yeah, it was on your PowerPoint. That's
Yeah. Again, basically it is dose dependent. That's what the graph shows. Yeah. And some people, like the current administration, they believe that some amount of radiation is really good. Like that's called as HORM, HORMOESI. Yes, I think. They believe in that, which I don't believe in. So here we talk about this one, right? What is this question? Okay. pen. Can I use a pen? Or maybe I can use my phone. That's okay. So imagine this is the patient head right here, and you got an X-ray source and you got a receptor here. So it's going to rotate like this to capture an image, right? So when it is following the path, so here this part from the X-ray source to here, there is a fine collimator that we use. So imagine this is the receptor. You know, you guys saw, some of the students saw the receptor like this big, right? Well, for the panoramic, it's like this big. But we don't open the whole receptor. We open only a part of it. That part only, it's going to capture a part of a condyle like this, and next view would be the ramus and maxillary region like that. So it will stack. So that's why we use collimator in this region, not to capture everything. So whole like slices will be combined together to form a panoramic image. Okay, on the segment 4, what is this? So here, somebody wrote very nicely, this is the orbit. And they wrote inferior canal, that is, what canal is this one? Yes. Intra-orbital canal. Infra, right? Infra. So, intra-orbital canal. So next question, the segment 9. It's not cervical lymph, it's cervical vertebrae. The question was, what is this? Cervical vertebrae. In radiation biology, slide 60 says that the absorbed dose of 45 milligray doubles the natural cancer rate in blah blah blah, and slide 62 says that dose from 0 to 50 gray has no risk for fetal death. I'm a little confused. Okay. So when we talk about the doses, it is, a few things are dose dependent. You are going to see certain effects only if there is certain amount of dose that is given to a patient. So 0 to 50, you're not going to see any birth defects. What else could be, like here, the next question. I've seen like cancer increases with the age, and another it says younger kids are more susceptible. Yes. So remember, as we live longer, we are exposed to multiple ways of radiation, and there is a likelihood of getting a cancer, like 40% more as we get older. That, whereas here the younger people, they are more susceptible, because that's why we take a lot of precautions, like we use thyroid collar, so that or the salivary glands are much more sensitive. Yes, as far as the sensitivity is concerned, younger people are much more susceptible to the cancer. Yes. Yes, as we get older, there is a likelihood of getting cancer is more. Yes.
Is it correct to say that as you get older, the total incidence of cancer increases, but young people are more susceptible to radiation?
Yes. 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 Yes, that is exactly right. That's why we take all the precautions in the world. Okay, so can you suggest what we can look? Okay, we will take a look at the pan, okay, in the next slide. Is it true that lead electrons are okay to be used in pan, but not lead electrons with thyroid collar? Answer is yes. Why? Yes, Dr. Oz effect, right? We talked about Dr. Oz. The person who asked, he didn't attend the class. Yes.
So we have to use lead aprons when taking cancer,
That is correct.
but we can't use just the thyroid part.
Just the, okay, yes. So there are like lead aprons only covering up to the neck region. There are lead aprons with the thyroid collar. With the thyroid collar we use in children. Yes. For intraoral images. Not really. So that's the distinction. Yes.
So to clarify, before reiterating again, kids, we use the apron and the collar.
Why? Because thyroid is susceptible to the
Because
cancer.
they have high sensitivity, but when it comes to pans, no one uses collar.
Yes.
Got it.
So somebody want to review the anatomy, right? Yeah. Okay, let's review. Starting from here, right? What is this structure here? Panda. What is this structure here? What about this structure here? Okay, how about this structure here? This one.
Trenches.
This whole thing. Okay, let me ask you this question. Okay, how about this one? So, what is this one? Okay. And what is this one? What is red one? Which border? Anterior, posterior, floor, and where will be the floor? Bottom, right? Posterior. Yes. So here is the, what you're seeing is the tuberosity, maxillary tuberosity. Okay. What about this structure here? Those who said maxillary sinus, they get 0. It starts with letter Z. What do you mean by zygoma? What is the other name for zygoma? Starts with letter M. Can you be a little more louder? I'm screaming here without lunch. And you guys are having lunch and you're Maillard process, right?
What was the red one?
What was the red one? Okay. What was the red one? What was the red one? Posterior wall of the maxillary sinus.
Can you repeat the last one? The top yellow one?
Zygoma.
What was that?
Maillard process. This one. Okay, what do you think is this one here? Anterior wall of maxillary sinus, or lateral wall of nasal fossa, right? So what about this structure here, from here to here? Floor, right? So what is this line here? The bottommost line here. What is this one here? Okay. And let's see. So this bottommost line is the hard palate. The top one on that is the ghost image of the hard palate. Remember, ghost images will be higher up, opposite side, and they will be horizontally magnified. Okay? As if you stretch something.
Can you show us the ghost image again?
Ghost image of topmost one. Okay, let me use the other color. Hopefully I can. Let's see. This color. Okay. Okay. Orange one is the, sorry, the yellow one. I thought it was orange, okay. Yellow one is the ghost image of the hot palette. The bottommost one is the regular hot palette. And here, what is this airspace called as? And what is this airspace called as? Okay, soft palate will divide into two things, right? Pharynx into two things. Nasal and oropharynx, right? No? I have to talk to Dr. Landerson. Okay, soft palate will divide the pharynx into two things, okay? Nasopharynx is above, top, and below is oropharynx, okay? And in that, if you look at the spaces here, okay? Now the space here is between tongue and the pharynx here, right? So what do you combine together? Airspace, okay. Okay, that's good. And what is here? What is this space called as? This little tiny teeny thing. It's between palate and tongue. Palatoglossal airspace. Yes, Josh.
Okay, so with those top two lines, the hard palette and the ghost image, the
Yeah.
soft palette, I recall on one of your slides saying that double images occur towards the center. So wouldn't those palettes be a center feature and produce a double image instead of the ghost image?
So here, yes. Also, in this one, yeah, it could produce double image. Also, it could produce a ghost image as well. Because it is, if you follow the first slide, the structures that are in that region will cause both, like cervical vertebrae, hard palate. They also cause ghost image.
So
Again, depending on where exactly they are located. That's why you should be looking at where the structures are located. Look at the picture, you'll get an idea. Yes.
Are both airspaces on the left the glossopharyngeal airspace? Like both parts that you
Yes.
circled?
Yes. Yes.
Okay, thank you.
I got the top one as the nasal, the bottom is the glossal.
So again, remember, depending on the question that I may ask, the soft palate will divide the two things, right? Nasopharyngeal and oropharyngeal. So where the pointer that I may ask on the exam, you have to answer that question. Okay?
Right.
So in general, I may ask, is it a glossopharyngeal or palatoglossal airspace? Something like that. I don't remember the question, so yes. I'm sorry, I did not get your question. Nasal cavity, that's a very hard question. Huh? I draw on nasal cavity. Huh. Nasal cavity. Well, all I can draw here in this pan is nasal fossa region, not exactly nasal cavity. So, yeah, so here is the, so here what you're seeing is nasal septum, inferior concha. No. Two different things. Concha also called as terminus, right? Yeah, so inferior turbinates, and then there will be middle turbinates and superior turbinates. Three things. How about this one? What do you think is this structure here? No, the white line. This white line. It's a ghost image of what? Yeah.
What is it?
So here, this part of the mandible is presented like here. So that's the ghost image of the inferior portion of the mandible. So what about this one? So it is from this part of the mandible. So it is higher up compared to this one. This is higher, and it is on opposite side. What else we have to review? Okay, what about this structure here? What about this structure here? Yeah, that's the epiglottis. What about this structure here? Those who said mandible, they get 0, big 0. So mandible is ending here. What is the biggest structure that you are going to see in the oral cavity, and starts with letter T? Yeah, that's the lateral border of the tongue.
That's good.
So here, the whole thing is the lateral border of the tongue. Okay. What do you think is this one? Don't tell me that's a white line. Oh, I don't see Andrea here. Okay. McKenna, you moved from there to here, okay. Which one? This one?
Yes, sir.
No. What do you see in the center? Supporting the neck.
Oh.
Starts with the cervical and ends with vertebrae, right? Cervical vertebrae. That's the shadow of that one. That's what you're seeing. So here you're seeing one and part of it and part of it. So these are double images that you're seeing. Yes, so in the center you could call that as a ghost image of the cervical vertebrae, and here is the double images of the cervical vertebrae. So here, this side and this side. This is the double image of cervical vertebrae. Any questions, guys? Yeah. Yes, ghost image of the cervical vertebrae. That's what you're seeing. And yeah.
On the side, the middle.
Yeah, inferior alveolar canal, also called as mandible.
That's the
Yes, I will for sure. Okay, so let me use a different color so that you will not get confused. Maybe black. So that's the inferior most portion or inferior border of the inferior alveolar canal or mandibular canal. This is the superior most schools. Anything else? Yes.
On the mandibular incisors, on the incisor surface, there appears to be a radiolucency there, this sort of triangle.
Take it under with
What is that?
So let me use a different color.
It almost looks like yeah, that triangle there.
There is a little shadow off. What do you call the second cervical vertebrae? There is something pointing out. Starts with letter D. It's four letter board. Starts with letter D, ends with letter S.
Wait, what?
Starts with D, ends with letter S.
Oh, S.
S like in Sam. And it's part of cervical vertebrae number 2. And there's something like this, it goes and it sits around the wrong portion of the cervical vertebrae 1. Then, so occasionally you will see part of dense, or it could be part of lips. When the patient is not closing, so you have to really look carefully and when you lose it, you can think away. Otherwise, that's where you are going to see part of them. If you look that way, you can see if there is a fracture. So here it's a lip, but that's where you are also going to see a superimposition. Okay? So that is lip. Patient did not close. Yes. Fissure, in this case, I can, yes. Okay. What's your name? Okay, Ashna. What are the structures that are coming out of the pterygomaxillary fissure? Which I'm not going to ask in the exam, but I'm just curious. Oh, that's a wrong. Over here. What is that? Ashna, can you?
The pterygomaxillary fissure?
Yes. Pterygomaxillary fissure. What it is famous for? I have to really talk to Dr. Rangers. Yes.
Is that also the lateral border of the maxillary sinus?
Yes. You all right? You all right?
The fissure is like outside.
Yeah, so it will fall like a fissure, like this one. What is the ganglion that is present there? You guys had a session or no? Let me ask you that question. No? No, okay, then that's
We are
fair.
currently supposed to be memorizing actually all of that, which means it's not happening.
Okay, that's, okay.
That's currently under memorization.
So here is that zygomatic arch that you're seeing. Zygomatic arch. So apparently it looks like nobody looked at it, or most of them, they did not look at the videos that I posted. Honestly, tell me how many of you did not look at my videos that were posted on Canvas? 1,
I didn't even know
2, 3, 4, 5, 6, 7, 8, 9, 10. You still have 2 days, okay? Good luck.
I have a question about the videos. There's one like that talks about like other things that you'll see, like tori and
Yes,
like different
yes.
stuff. Is that stuff on the midterm or no?
That's stuff on the midterm.
Yeah, it's called
Ah,
supplementary information.
Probably not on
Okay.
your midterm, but it would be helpful, like, if you look at those things, you'll kind of get an idea what are the things that you would most commonly see in the workshop.
Okay.
Because you guys are stepping the legs into dentistry, right? Into the oral cavity, so you should know a few things. So
Okay.
the whole idea is that I may cover some portion here, something there, and then somewhere there. Then I would ask you to connect the dots by yourself. Right? You guys are adults and then you know how to read, right? No, I don't have to spoon feed. That's my understanding. Yes? Any questions? Yes?
What is the circle above number 14 and 15?
What is the circle of number 14 and 15? Can you come here please and show it to us so that I can explain it nicely? Because I'm kind of confused now with your question.
It's the one you
What I think might be different from the student that he is thinking. So let's.
Can you reach that?
Awesome.
Yes,
me, I feel like honey dough.
Yeah, I can reach it.
Oh, you
Oh, he can reach it. Oh, almost.
Barely.
Yes. Yes. Mina, what do you think?
Not sure, some kind of sinus?
Ashley. The circle. Okay, that's fair enough. Yeah. How do I pronounce your name? Min Soon? Is that correct? It's easy to remember the gap between palate and tongue. I won't be coming and telling you guys in your midterm, right, exam? Yeah.
Wait, didn't you say that was the name of
Wait.
Oh, it's the part
No, I did not say that as a name. Here I said, the soft palate is the dividing part that you use that as a guideline to say that where is the nasopharynx ends and oropharynx starts in this particular region or the lateral part of this region. So here, what you are seeing is the soft palate. So above this region is nasopharyngeal region. Below this is oropharyngeal region. That's what I was trying to.
Wait, can you say that again? I couldn't hear.
Okay, soft palate is the guideline that you use to differentiate between oropharynx and the nasopharynx. So anything above the soft palate is nasopharyngeal region. Below that is oropharynx. Okay. Yes, and if you see the space between palate and the tongue, palatoglossal. And if you see the space between tongue and the pharynx, glossopharyngeal. Make sense? This glossopharyngeal airspace could extend all the way from here all the way to here. Yes. Yes.
On your image where you identified all the parts, it looks like you identify it as the palatal glossal airspace.
Yes.
So is that correct for where that yellow circle is that also displayed out?
Yes, you are right. I'm correct. Yeah.
Huh?
How are we supposed to differentiate that
Okay. How does soft palate is okay. Let me ask you this question. If X-rays are going to pass through the air, how does that look like? Dark, right? Soft palate, it has got some soft tissue, right? So you can differentiate soft palate from the airspace.
But with the soft palate, let's say if it was like more white, if it was white,
So you should understand where the soft palate is starting from, where the hot palate ends and the soft palate starts, right? So this scenario is like where the continuation or junction of red and blue on top area. That's where the soft palate is starting.
Thank you.
Yeah, like here. This is the area the soft palate is starting. Yes. Stylohyoid ligament calcification, okay. Versus tongue. That was your question, right?
No, but like, how do you differentiate?
Okay, styloid, okay. Okay, styloid is made up of with what? Styloid process is made up of with what? It's a bone, right? Yeah, so how do you see the bone as? White. Compared to tongue?
Right. From a higher, would that be lower, upper, lower?
And if you see something joining those two things, then
So it would be sitting like on above the hyoid bone, like connected to hyoid?
so the stylohyoid ligament is basically a ligament that starts from the styloid process and goes all the way to the hyoid bone. Yeah, sometimes it may be continuous, or it could be interruptions, or you could see one calcification in this region and the calcification. Yes. Technically, yes, the answer should be yes, but there could be a lot of variations. Any other questions? Yes. Uvula on this radiograph? No. Yes.
How do
Ashley.
you differentiate between the nasopharyngeal airspace and the palatal-glottal? Are you technically not supposed to see the palatal-glottal if they have their tongue in the proper position?
So palatal-glossal airspace is if, imagine this is the palate and the tongue, right? So we would ask the patient when we are requesting a pen, we would ask them to place the tongue to the roof like this. Then you're not going to see any airspace.
Okay.
If the patient is not going to close like this, if there is a gap, it is going to be challenging for us to diagnose.
And see the root.
Yes, since it is kind of whole thing, generally you would see the radiolucency from one end to the other end. So this is an exception here. Only part of it is not closed, but other tongue, part of the tongue is closed.
Because that image would lead me to believe that it would be the nasopharyngeal airspace.
So here, so generally nasopharyngeal, yes, you could use the term, but technically it's not part of that.
Okay.
Because when you see nasopharyngeal is above the soft palate region, like this one.
Okay. So it's higher.
Yes,
Good.
it's much more higher, yes.
So which would be correct, because your slides have that circle labeled as nasopharyngeal, like 4 times. So which are we supposed to?
So if I ask you any question related to this region, that's where I would be concentrating and asking the question to differentiate between nasopharyngeal versus oropharyngeal, not in this region.
But that's glossopharyngeal.
Yeah. Somebody is trying to take me out. 30 questions, multiple choice. Yes.
How much of it is this?
And after that, we are meeting here because we have to finish the class.
So our exam is at 8. Exam is at 8.
8 to 9, and 9 is exam. Most of the students, they finish in 15 minutes.
No, 8. It's at 8.
Between 8 and 9. Exam starts exactly at 8. If you are late, I can't help. Yes. Good question. I don't recollect, but chunk of question should be the chunk. I don't remember exactly. Maybe, again, don't quote me on this, okay? But be anywhere between 12 to 15 questions.
What do you well, 15 questions on the 6 titles, 12 to 15.